Next speaker is with the WSP Group. Many of you saw his presentation this morning in the training. David Bownass is going to speak about some of the projects that they've been doing in the areas of green building and sustainability.
As has been mentioned, I believe I'm the last speaker, and at least 3 people have told me to be as quick as possible. So we will run through high level on these particular projects. Press right. First project I wanted to talk to you about was Stansted Airport. It's one of the major feeder airports around London in the UK. It's recently applied for an extension, a new terminal, and new runway. Unsurprisingly, a number of people are not very happy about that. Yesterday it was on the news, they were storming the Houses of Parliament. So it's quite a difficult project to work on, and consequently our contribution to it is the energy strategy, which is a subset of the overall sustainability strategy. And because we know it's going to public inquiry, it's a very rigorous process. What the timeline, carbon timeline here is showing us is that the development in 2006 measured its overall carbon emissions, and they made a commitment that when they had completed the second terminal and runway, that the overall carbon emissions by 2030 would be no greater than they were in 2006, which basically means we have a lot of work to do in terms of squeezing the carbon out of the new development and going back into the old development and robustly taking carbon out of that as well. It sounds simple in practice. It's been a very long process. This has been developing over the last couple of years. It's accelerated in the last 6 months. Well, the timeline is showing is since 2006, the carbon emissions have been growing. From around 2010, there is a big process in place to try and take carbon out of the development, the existing development. And the timeline then goes down. In 2015, we start to build the new, and the timeline then goes back up again. In terms of trying to predict carbon and CO2 emissions going forward, I think I mentioned this morning, we spent a lot of time trying to cast forward what we think the overall environmental conditions are going to be in 2015, 2020 and in 2030. Again, in the UK, there is potentially a decreasing carbon content of grid electricity, which also has a major effect on us as we go beyond 2030. In terms of a solution, this is actually one of the options. It's quite a complicated solution for the buildings. The building heating and cooling loads are reasonably well balanced. And what we have is a heating loop that goes around the site, and we have a cooling loop that goes around the site. And in between those 2 loops, this isn't actually the final option. The option that we went for wasn't CHP, it was a series of chillers. So we've got the chillers operating all year round. When there's no cooling demand in the buildings, the cooling is stored in underground piles, which is what this is trying to demonstrate here, and here, and here. Because we've got a constant heating load all year round. So we store the cooling when there's no cooling demand, and we use the heat rejected off the chillers to heat the buildings. Quite a clever solution, which I'd like to think is quite a clever solution. Of course, when we actually measured the carbon, what was interesting out of this process was that only about 15% of the overall carbon came from heating and cooling the buildings. And it was mentioned previously by the lady who was talking about BMSs. We found that the residual carbon, that's about 85% of the carbon, came from lighting loads and came from IT and process loads within the building. Bearing in mind the carbon content of grid electricity is quite high in the UK. So in many respects, we spent a lot of time, money and effort concentrating on trying to deal with the buildings, but the larger part of the carbon was actually on issues that were quite difficult to deal with, and really the only thing you could do was squeeze down the demand. And again, that was mentioned this morning with regard to lighting design and IT design. Second project, Dubai World Trade Center. I worked on this project a couple of years ago now. It's coming out of the ground. It was the first LEED Gold office development in Dubai. What was challenging about it was that the local authority at that time said you have to take our district cooling water and you have to take our power. You can't generate anything on site, no renewables. So to get LEED Gold, to meet the energy aspects in particular, we had to make the buildings work very, very hard. And if you look at the buildings that's adjacent, these are the towers that were there already, Emirate Towers, I believe, and they are essentially covered in glass from head to toe. If you look at the phase 1 development, what you see is a lot of balconies. The glazing requirements were very stringent. The area of glazing was limited to about 30%, so we had to make the building and the building systems, that bottom part of the energy hierarchy, work particularly hard to get the energy components for LEED Gold. Moving swiftly on. This is a project in the UK, it's 1,200 homes. They're all designed to be zero carbon, and when I say zero carbon, that means that within the development, the energy that's consumed within the development has to be generated within the development. Again, we touched on this morning with regard to all homes having to be zero carbon by 2016. He had a mixed bunch of residential on this site. He had some 3-bed semis, 4 beds, 1-bed flats and 2-bed terraces. And what that gave us was different load densities across the site. So we ended up with a number of different options to address the load densities. Forgive the wind turbines on top of the houses. They're only there for aesthetic purposes. They're not actually going to be provided. But around where we have the low density, the homes can look after themselves with solar thermal and PV. Where we start to get to medium density and high density, we had a number of options. We had a primary energy plant with distributed heat network, but because it was phased, we also looked at distributed energy centres around the site. And just to top off the power supply for the areas that weren't looking after themselves, there was a small 1 megawatt wind turbine. I suspect that's one of those projects that since it's been got past this stage, like many in the UK for residential, is on hold at the moment. Sheffield Sevenstone, this was actually a mixed-use BREEAM Excellent development in Sheffield. I think the previous speaker mentioned BREEAM Very Good. We were very, very fortunate on this development. Sheffield is served with a waste-to-energy plant where outside the city they generate power by incinerating waste, and you get a very, very low carbon hot water distributed from the waste-to-energy plant. And because it's very low carbon, it meant that we were able to get BREEAM Excellent and satisfy the energy requirements relatively easily. I put Masdar on the slides just to give you an indication of the aspirations that exist in parts of the world. Masdar is a development near the airport in Abu Dhabi. Its ambition is to be zero waste, or the first zero waste, zero carbon city. We were involved with the infrastructure design at Masdar. And just to give you a couple of useful facts, they did an amount of a comparative analysis, and the infrastructure for normal design was about £3 billion. The infrastructure for a 50% carbon reduction was about £6 billion. But when they went to zero energy, the infrastructure cost was £12 billion. So what that says to me is you can make some pretty good improvements for a relatively small investment, but if you want to go to zero carbon at this moment in time, it is very, very expensive. I should just add as well, we are working currently on rewriting the building codes in Dubai around the principles of LEED and BREEAM. So there is quite a push now in that part of the world to create a step change with regard to their sustainability criteria, because they have been criticised a lot in the international press. Hirsch Tower, just mentioned in passing, first LEED Gold commercial building in New York. Can't say a lot about that. It's not actually one of my jobs, but I know we're very pleased with it. And the final project, this is just to show the scale of the kind of projects that we do. We do big projects and we do small projects. Geismar Prison has about 600 inmates, and they don't always eat all of their food, and about 6 meters cubed of food waste is generated every week. We take that food waste and it goes into a series of bins. The bins are excited with a bit of heat. They compost quite quickly. Off that composting process, there's a bit of methane. We take the methane off that process, it goes into a boiler, it provides the heat to agitate the waste, and after about a week, slightly longer, pardon me, it's about 3 weeks for the waste to go through the cycle, and we end up with compost. So we significantly reduce our food waste off-site. We end up with a compost which can then go to fertilise the site. I can only think of one slight drawback with that particular project, in that because the content of the waste is mixed, in the UK you're not allowed to export compost that comes from that particular process. So I can see in a few years' time they're going to have piles and piles of compost and nowhere to put it. However, The principle is one that we've applied on a number of projects since. We're working on another project where they have no topsoil. And we have an AD plant proposed there where we're trying to, or we'll be using the compost to create the topsoil. Apologise for a very, very quick flick through a number of different projects, but I think that, that brings us to an end.